All right, today I'm gonna make a video. I have a MEP 803 alpha generator. It's also gonna apply to an MEP 802 alpha generator and really any other military generator for the most part. How to properly set up out in a field like this and do a safe load test of the generator to make sure that it's functioning properly and everything on how I recommend to do it to make sure that your generator is going to give you long stretches of service without giving you any problem. All right, I just wanted to say something before going any farther in the video. I am not a professional or licensed electrician at all, so just take everything that I'm going to put in this video as advice. I service these generators both on the electrical and the mechanical side all the time. I've used them out in the field like this at my off-grid cabin and for my home as backup power for quite a bit. I have thousands of hours running them collectively and I have not had an issue, but that doesn't mean that I am doing everything 100% right or that you will follow every step that I have done completely right and that you are not going to have some sort of problem with your generator and something is going to go wrong. So that's the reason why I decided I wanted to make this video and show all the steps like proper grounding, making sure that you know how to do the proper neutral ground bond, not overloading your generator too much, and just to make sure that it's properly functioning and that you shouldn't do the very first load test on your home in case you do have a problem with your generator and you burn out all kinds of electronics on your house. You should be doing it out in the field or disconnected or in your driveway, completely separate from anything that you could burn out in your home in case there's a problem with this. These are great generators if they're functioning right, but just like anything else mechanical, it could break down and it could have a serious problem and hurt your electrical system or it can hurt you. So just be careful and take your time. Do what you're supposed to do, follow the technical manuals, just be safe about it. You always hear people talking about being safe and stuff like that, but it's really important when you're working with it because these will produce enough electricity to hurt you. So just be careful. All right, and here's the grounding rod kit with the slide hammer. So you get the 3 grounding rods and the 3 connectors for connecting them together. You'll have the clamp for clamping the grounding wire on. There's usually this that can go in the final connector for if you don't have the slide hammer kit, you could just hit it in with like a sledge or something like that. And then your grounding wire, and they usually have this on there. I think it's kind of like universal because they use the same kit for all kinds of different things. But on the generators, this isn't needed because you're either going to be putting it on the nut that's on your trailer or you attach it directly to the grounding lug on the generator itself if you do not have a trailer. And as you can see, since I have mine on a trailer, there is a grounding wire that is run up into the lug, which we'll go over later. So basically the way this works is these connectors all thread together and you hammer one piece in at a time. And I guess if you're in really challenging terrain, you know, use multiple of these and you can parallel them in the ground as well. I have sandy loam soil, so this shouldn't be hard to get into the ground at all. Then with the slide hammer piece, the idea is you have this fixed at one end. You thread this into the top of the one that you're using and you can use that to slide weight down. And then when you're taking it out, you thread that end in and you slide that up. Same as like if you're using it to pull a bearing or something like slide hammers. So I'm gonna go ahead and get this grounding rod in the ground. All right, it's in best I could go. I'm softer than newborn baby number 2, so couldn't get the whole length of this 3rd rod in the ground. I guess the sandy loam is a little bit thinner in this particular spot and I must have hit the clay. I'm pretty sure I got a good ground. There's ways of testing. I do not have a ground testing meter and I'm pretty sure you don't either. So this is certainly better than not having one. So I got it connected over here to the trailer. And next we'll talk about inside. All right, inside here in the panel, You can see, looks like a rat's nest, but it's really not. I have two 30 amp leads running out, and I have it set up for single phase 240 volt at the S8 switch. And it's also going to monitor that at the S6 switch. Now, hot leg number 1 is coming off L1. Hot leg number 2 is coming off L3. There's the copper ground wire running to the ground, and then the neutral. This right here is built-in neutral ground bond. Now what that is basically linking together your ground and your neutral. In any electrical system, you want that link. If you're hooking this up to your house, you need to remove that link. But this is not to talk about how to hook it up to your house. But anyway, make sure this is in place. If this is missing from your generator, in order for this to be safe, either make something like get a piece of copper and make this back here, or you can just run a wire between ground and neutral. Some older generators, I believe this will be labeled as L0. And if you could see, so that's quick removable, you can see, you can just loosen that nut like a quarter turn, and then this will kind of like rotate to the side. I'm not gonna go over how to properly wire up a pigtail. If you're not capable of that, pay someone to do it. All right, everything's all hooked up and ready to do the load test, including external fuel. Fuel tank vent is open, and if you don't know about those two things, I'm gonna splice in a clip now. If you are unaware, on the inside of the fuel cap, you can see how I have this little tab rotated to open and closed. If you're transporting it, closed seals up the vent, and open is for when it's operating so that the tank will breathe. It's on the underside of the cap. I have my external fuel connected and open. If you don't have a setup for this, highly recommend it. It makes it way easier if you need to run for extended times. I have an adapter kit, so you could end up making your own at a fuel line you can go get at the store. Link is down in the description, or go to my website and find it at my eBay store. The next thing that I wanted to talk about, overloading the generator. Because if you're new to these generators and you're watching this video, you may be thinking, the MEP 803 Alpha you're shown in the video is a 10,000 watt generator, and you've talked multiple times here before we even get into it, and you're saying you're putting something like 12,000 watts on it. The military underrates the generators. So they'll handle more than what their rating is. Generally, they rate them at about 80% of what they can actually really put out. All of those things together make it really safe for the most uneducated end user of the product, and also to give you that little bit of extra power out in the field for those who do know what they're using. But what I also mean about overloading the generator is there's the fault panel, and part of that fault panel is overload. If you put too much load on your generator, that overload fault is not going to trip and automatically open up the contactor that puts power out. It's actually just gonna bog your generator down, and it probably won't stall out, because I've done it. This is coming from experience. It's just gonna make the engine like sputter, like barely run, almost like it doesn't have enough fuel. It's really bad for sensitive electronics. It'll just continue to run like that, so don't overload your generator in that sense. Like, if what the overload fault is for on it is if it detects overcurrent that's just a little bit too much overcurrent for too much time, that's gonna then damage, because it's gonna create too much heat in the generator head. So say if you were running like 13,000 watts for 5 or 10 minutes and it starts generating a little bit too much heat, then it will cause it to trip. But if all of a sudden you jam 15,000 watts on there and close the contactor, it's just gonna bog the engine right down. Eventually, I'm going to get an actual good load bank, but quickly I'm gonna talk about this. In my opinion, I think using electric heaters is the best way to do this, because you know exactly how much power it's gonna put out. It is a 1 power factor, and if it's a 5,000 watt heater, for example, at 240 volts, it's gonna pull 5,000 watts. If it's a 110 volt heater at 1,500 watts, it's gonna pull 1,500 watts. You don't need to worry about it when it starts surging really high or it being some weird anything. It's just, it is what it is. And then you can look on the panel if you're unsure, say like you bought it used or something like that. So at the bottom of this 110 heater, for example, this is the first one that I saw. You can see right there, power, 1500 watts. Now that's on high. At low, I think it's more like 13. I'm sure the owner's manual tells you some more. These say it right on the front. A low setting is 3000 watts, high setting is 5000 watts. These are awesome. This exact one, I don't know, they change depending, but these are available on Amazon and they're cheap, especially if you buy them off season. Instead of going out and buying some stove that you don't know how old it is and if it's actually putting out the power, considering how much time and money you might have invested in setting up a generator like this and to properly load bank it, to buy one of these if you have an MEP 802 alpha, or two of them if you have an MEP 803 alpha, and know that you can get 100% load, and then add on like a little heater like this, just buy it and you know that you have a good clean power that's easy, and then you have backup heat if you need it. Anyway, enough of that rant, but I'll put some links to these heaters and everything. Wanted to displace this little spot in here to talk about power factor. I thought I was going to be able to condense it enough to put into the time lapse, but I couldn't. The best way to describe it is think of power factor as a percentage as far as it goes on the gauge. So the gauge is a 0.8 power factor, so that would be an 80%. If the device or devices that are hooked up are at a 1 power factor, that is a 100%. So in the sense of this video, when we're talking about the heaters and stuff like that, they're a 1 power factor. So that's a 100% load of 5000 watts. I know this can get really confusing and it's probably more in depth than this, but this is the most basic way to explain it and how I understand it. So if you were to take the two 5000 watt heaters that I showed in my example and you put it on and you load it up, the gauge is going to show about 80% load because it's a 0.8 power factor. So the gauge is true if you know how to read it. So for example, with everything that I have on the example of my load bank, it shows quite a bit. It shows a little over 100%. In reality, it's a lot over 100%. It's somewhere close to like 130%. I'll have to put the exact number up. That's the easiest way to explain it. Then when it comes to your devices, if your device is not a 1 power factor, it will usually say it on it, but it might not. That's the reason why when it comes to load banking and load testing, using electric heaters is the best. Because if you turn them all the way up, they're gonna stay on no matter what and just keep making heat. They're not gonna cycle. Moving on to the generator. I'm assuming at this point that you've already worked out all the mechanical issues. Your fluids and everything are good. Here's another thing. Having something like this that you could plug into the convenience outlet, and it's gonna give you a whole bunch of data, like what your voltage is, hertz, just to kind of compare against your gauges here. It's good to have. Do not plug in stuff like your 110 heaters into this. This is meant for like little lights, little battery chargers as a convenience. That's why it's called a convenience receptacle. Start it, get your gauges where they need to be and check against them and let it warm up. Generally, I notice at 100% load, you're gonna want your hertz gauge around here. Now, as it's warming up, what you can check against, you can move this switch to here, 120 volts, 120 volts, cool. If that's off, you can use a little flathead screwdriver and adjust these. Just be careful. Hertz. About right, 62, there you go. Master switch, prime and run auxiliary fuel, because I'm gonna pull auxiliary fuel. So we're letting it warm up right now. Move this back where it needs to be. I'm gonna let that temperature gauge come up. All right, we're up to operating temperature. So I'm gonna go ahead and close the contactor. So we're putting power out. Now I know with my little distribution box here, every time I need to reset these little GFCIs that are on here, What I recommend next is don't just take your entire load bank and turn it all on, because basically what I got here, if I turn it all on together, is 12,900 watts of power at a 1 power factor. That's going to show different on the gauge, and that's something that confuses people because the gauge is a 0.8 power factor. As the time lapse is going, I'm going to explain that a little bit more in depth. I'm going to set a timer for 5 minutes apiece, and I'm going to turn on each thing at 5 minutes, starting with the 5,000 watts apiece. I'm going to start with this one. I loaded it completely up with everything I showed you previously in the load bank. Once I loaded it up that much, it started spewing out a little bit of smoke, which is pretty typical of a surplus generator because they never really exercised them all the way. Add 20% onto that, and that's what it's running at, give or take. So I started my 6 hours, and we'll see. Looks like that auxiliary pump already kicked in and brought some fuel in because it was at like half. So everything's doing what it's supposed to do. Time will tell. Last thing I want to talk about is how long you should do the load test for. It's funny, I thought I actually said it earlier in the video because this is probably the most important thing that I want to get across. People think just because the engine runs good, that means that the generator is good and that it shows power. That is not the case. I have almost always found, and that came to be, as you'll see at the end of this video, that just because it runs right and just because it shows power on the meter, once you put it under full load and exercise it, that is when your problems are going to come up. Do the test for 6 hours, starting from when you hit 100% load or more, if you decide to do more. And if it fails during that time, you fix the problem that caused the failure and you start over again. So if you made it 2 hours and it failed, you don't fix the problem and then go 4 more hours. You start over again at that 6 hours. I promise you, if you do it that way, you're gonna have an extremely reliable machine. I can't stress that enough. I've done that on multiple of my own personal machines, and they've gone hundreds and hundreds of hours, and basically I've neglected them afterwards, just using them and abusing them, and they've always started and ran hard when I needed them to at my off-grid place and here at home as backup. So that 6 hour is such a key mark because normally it's going to fail within an hour or two. And the last thing that you want to happen is that failure the first time that you go to use this and you thought everything was good, and at 2 o'clock in the morning, you know, you woke up to a hot house or listening to this thing sputter out and diesel fuel leaking all over the ground or something like that. Or, you know, it did what I was just talking about with overload and the thing is chugging away in the middle of the night. You didn't even realize it. Freaking, there must be a wasp's nest over here or something. And it's gonna freaking fry electronics in your house or damage your generator that you just spent so much time working on. So can't stress enough, 6 hours. Make sure it passes the 6 hours. All right, the generator's back in the shop. It failed my 6 hour test at about 2.5 hours. So I need to do some work on this, but really the point of what I needed to do for the video was show you how to set yourself up and do the 6 hour load test. That's the whole point of this, of the point getting across. But I don't need to show you my 6 hour load test passing. The point is you know what to do. And then taking apart your grounding rods, I already explained taking it out. But if you made it through your 6 hour load test, the only other thing is don't get to 6 hours, open your contactor and shut it off. Open your contactor after doing the opposite of what I did at the beginning. Slowly take your load off if you can. You know, go from full load and every 5 minutes take one piece off till you're down at like 0. Then open the contactor and then say as you're disconnecting all your wires and picking the stuff up, give it that 5 to 10 minutes to run without load. So that way it lets the generator head cool down and all that stuff, and then shut the generator off and pack it up and put it away. That's about the only thing that I wasn't able to show you by this failing while I'm recording the video. Other than that, I hope that this was helpful by getting the point across. A lot of people already know about this. A lot of new owners don't. They think, hey, I saw that it's putting out power, it's going to be good. No, there's a lot past that. And then you'll see a lot of people on the Steel Soldiers forum, the first time they went to go use the generator as backup power is when they found failures because they didn't do something like this. Anyway, hopefully I don't have a big serious problem with my generator here. I've been having a run of bad luck with them. But anyway, links in the description to things that I showed in this. They're affiliate links, so they help me out. You know, I get my 3 cents instead of them giving the ads to somebody else. And you watching the video through helps me out too. Thanks.